Today we'll start the second part of block 4, which is magnetism. Electricity, we are done with electricity. Now the second part is magnetism. First thing, what is the origin of the magnetic field, or why the material behave like a magnet or having a magnetic field? So what is the origin of the magnetic field? The origin of the magnetic field is a motion or the movement of the charged particles. Whenever the charged particles are moving, they always produce magnetic field. So origin of the magnetic field is the movement of the charged particle. And what are the charged particle? When we compare the atom, like when we take an atom, inside the nucleus of an atom we have neutron and protons. Proton are positively charged, neutron, their net charge is 0. Around the nucleus, subatomic particle electron is revolving, or electrons are revolving in the region which we call shell. So there is a proton, which is a charged particle, and inside the nucleus, this proton is not stationary, it is moving. It's not stationary at one place, it is actually moving. So there is a movement of the charged particle inside the nucleus, and there is a movement of the charged particle around the nucleus, which is electron. So due to the motion of the charged particles, electrons and protons, the atom will behave like a magnet, and we call this domain. So domain is a term which is used for atom which is behaving like a magnet. Because of the movement of the charged particle, there are protons, there are electrons. As these particles are moving, they will produce magnetic field, and due to this whole atom will behave like a magnet. And how we represent this atom? We represent by an arrow. So atom which is behaving like a magnet is represented by an arrow. So according to this theory, because everything is made up of atoms, so it means every material should be magnetic material. But in reality, all materials are not magnetic material. There are only specific materials which are magnetic. Rest other materials are non-magnetic or not behaving like a magnet. What is the reason why some materials are behaving like a magnet and some materials are not behaving like a magnet? The reason is the alignment of these domains. Like example, you have two materials, both consist of atom because every material is made up of atom, and inside this material, because it is made up of atoms, so atoms are there means there will be domains or small magnets. But if a material which is having these domains and these domains are random, not arranged, so for a material in which the domains, the atoms are not arranged in terms of magnetic field, so if domains are random, what we call that as a non-magnetic material. But there are materials in which there are domains, the atoms are there, and these atoms are arranged in a regular pattern. So when atoms are arranged in a regular manner or regular pattern, that material in which the domains are aligned, known as magnetic Is it clear the basic concept of the magnetic field? So magnetic field is due to the particles, the movement of the charged particle. So if everything is made up of atom, everything should be a magnet, but in reality it's not. What is the reason why some materials are magnetic and some are non-magnetic? Because the atoms, in terms of magnetic field, if a material, these atoms are not aligned or arranged, so they cancel out the effect of each other. Overall, material will be a non-magnetic material. And if the domains are aligned, arranged in a regular manner or a pattern, we call that as a magnetic material. Is it clear the difference between a magnetic and a non-magnetic material, as well as the origin of the magnetic field? So atom consists of charged particles such as proton and electrons, and because of these charged particle, atom is behaving like a magnet, so we represent that atom by an arrow and we call that as a domain. So materials are made up of lot of atoms. If these atoms are not arranged, not aligned, we call that material as a non-magnetic material. But if these atoms are arranged or aligned, we call that as a magnetic material. Then what are magnetic poles? Magnetic pole, it is region where magnetic field is stronger compared to other parts of magnet. So region, the place where the magnetic field or magnetic force is much stronger compared to other parts, we call this region as a magnetic pole. Like example, you have a material in which the domains are aligned or arranged. So this material, because the domains are arranged, so we call this material as a magnetic material. But even within this material, you will find a region, the place where the two places where the magnetic field is much stronger as compared to any other part. So if one of the pole, we call that as a north, then the other opposite, because in terms of direction, the opposite, if you have north, opposite will be south. So if one pole is known as the north, the other one is known as the south. So for every magnet, the domain normally it is termed for a group of atom, but it vary from material to material, but you can consider one atom as one domain. If there is one atom, you can say that is one domain. So there are millions or trillions of atoms in a material. If they are aligned or arranged, we call that as a magnetic material. So when you check the material, there are two parts within the material where the magnetic field is much stronger than any other place, and these ends are known as poles. So the two ends, the two regions where the magnetic field is stronger than any other part, we call pole. And for a magnet, if one is known as the north pole, the other one, because opposite of north is south. So for magnet, one pole we say north, then the opposite pole is refers to a south pole. And for every magnet, there exists two poles. Even, like example, if you have a permanent magnet, you have a permanent magnet. So there are regions where the magnetic field is stronger than any other part, we call that as a pole. So example, if the red shade is representing the south pole and the blue shade is representing the north pole. So we have south pole and north pole. Now what we do, if we break this magnet into two half, so when we break this magnet into two parts, so still it will not be like one side will be south. So when the magnet breaks into two half, then again it will have two regions. So this was south originally, and this one is north. But as we break down, this region will be north and the other region will be south. So magnets always have dipoles. The term dipole means two poles. You will never find a magnet which is having only one pole. Magnets always have dipoles or two poles. So even you break down into smaller piece, you will always find it will have both poles, north and south. The term north and south, it's only due to the opposite. It's why it is called north and south. The idea of the pole is the region where the magnetic field is much stronger than any other part of the magnet. The reason for that, because why when you break the magnet it is always having a north and south, because every atom, when you have an atom, each atom is having its own magnetic field. So one side it is south and another side it is north. So I'm not breaking the atom, I'm breaking the material. So when I'm breaking the material, the atoms are still there, and due to the magnetic field of atom, the material is behaving like a magnet. So whenever you break down the magnet into very small pieces, you will always find there is north and south. So for magnets, there is no monopole. Monopole means you don't find a magnet with only one pole, south or north. If there is a north pole, definitely there will be a south pole. Then magnetic field, it is region around the magnet where other magnetic materials can experience force. The magnetic field is a region around the magnet where other magnetic material can experience force. We call that as magnetic field. The difference between the charge object and the magnet, look, example, you have a material which is having atoms. A charge object can be positive, negative, but for magnetic materials, it is not necessary that there should be a net charge. Overall, it can be neutral, but it can be a magnetic material. These are the atoms, because I'm not drawing the nucleus and electron. Due to the particles which are inside, it is creating a magnetic field. So each atom is behaving like a magnet. The arrow is representing the atom is acting like a magnet. If these atoms are aligned or arranged, what will be this material? This will be a magnetic material. But if you have material made up of atoms, and these atoms having magnetic field, but these magnetic fields which they produce are not arranged or aligned, so what will be this material? This will be a non-magnetic material, means it will not behave like a magnet. But what is the meaning of charge object? The term charge object means Like if electron transfer, if this material transfer electron or gain electron, if it transfer electron, this will get a positive charge. If it gain electron, it will get a negative charge. So the resultant charge appear when it gain electron, it will be negative, and when it lose electron, it will be positive. So a material can be charged, it can be magnetic at the same time, or a material may be neutral and behaving like a magnet. So both possibilities are there. Is it clear? The difference between the magnetic material, basically the magnetic material or magnetism is due to the particles which are inside the atom. They produce a magnetic field. But for charge object, due to loss or gain of electron, so when domains, these atoms are aligned, we call that as a magnetic material. If the atoms are not aligned, we call that as a non-magnetic material. This is in terms of magnetic field, like comparing the atoms. But when you want to compare the charge material, like you have a metal sphere, you have a metal sphere, which is the structure of the metal, the lattice of the positive ion and the delocalized electron. So if this material, like having electrons, if more electrons are added, net charge will be negative. If electrons are removed, the net charge will be positive. So magnetic material can be charged as well. That is totally different thing. Like they don't have relation that a magnet can, you can have a material which is magnetic as well as the charge. Charge is due to loss or gain of electron from the structure. And magnetic field is due to the atoms, the alignment of the atoms or domains. If atoms or domains are aligned, the material will be a magnetic material. The magnetic field, how we define a magnetic field, it is region around the magnet where other magnetic materials experience force. We call that region, that space, as a magnetic field. So it is region around the magnet where other magnetic material experience force. We call that region or space as a magnetic field. Like example, I have a magnet and with two poles. One side is a south pole and the other one is a north pole. If I place a magnetic material, like example, if I place a magnet here nearby, which is north and south, which direction this magnet will move, towards or away? Which direction this magnet will move if I bring north pole towards another north pole? So like charges, like poles also repel each other, so this will move away. And if I bring a south pole closer to this, so which direction it will move? It will move towards. And the space, the region, so it will move towards. And the space or the region around the magnet where other magnetic material can experience force, this space this region, this whole space, what we call this space, we call that as a magnetic field. So the whole space around the magnet is refers to magnetic field. Like if I place, example, I'm placing a material north and south, it should, which direction this should move? Another small magnet I place closer to, like far away from this south pole, which direction it should move, towards or away? So it will not move, it should move towards, but it will not move. Reason for that, because it is outside the magnetic field, it is not in the region where it can experience this force. That is why this object will not move. So the space, the region where the other magnetic material can experience force, we call that space or a region as a magnetic field. And what is the direction of the magnetic field? The direction of the magnetic field is same as direction in which North Pole experience force. So the direction of the magnetic field is refers to the direction in which the North Pole will experience force. So example, if I have a magnet, a permanent magnet, and I place a, or if I want to point or show the direction of the magnetic field, so we have North Pole and South Pole. So if there is a North Pole, which direction this North Pole will move, towards or away? If I place a North Pole here, anywhere, which direction this North Pole will move? So it will move away. So that is why the direction of the magnetic field is out from North Pole. All the magnetic field lines are pointing, their directions are out, because direction in which the North Pole experience the force, that is known as the direction of magnetic field. But if I place a North Pole near the South Pole, so it will attract, so it will move towards. So direction of the magnetic field lines, they are out from north and into south. So when we join these lines, the field lines, it will create a region or a pattern, and this region or the pattern is known as magnetic field pattern, and the region is known as magnetic field. So this is how we represent the magnetic field of a permanent magnet. So direction is out from north and into south. Is it clear? The concept of this is the direction in which the direction of a magnetic field is always a direction in which the North Pole experience force. So if there is a North Pole near a North Pole, it will move out. If there is a North Pole near the South Pole, it will move towards. So direction, the standard direction of a magnetic field is always out from north and into south. So whenever you're drawing a magnetic field pattern, your magnetic field lines, it should always be out from north and into south. Then to work out the pattern, drawing a magnetic or plotting a magnetic field of a bar magnet, if you want to plot a magnetic field of a bar magnet, what we can do, we can use plotting compass. What is a plotting compass? Plotting compass itself, it's there's a needle. So this is a plotting compass. Plotting compass needle itself, it is a magnet. The arrow, the head is the north pole and the tail is the south pole. So we can use a plotting compass to work out the magnetic field of a permanent magnet or a bar magnet. So how we can use, example, this is a bar magnet and we want to plot the magnetic field of a bar magnet using a plotting compass, or if we want to trace the magnetic field. So this was north pole, here is south pole, and we want to trace the pattern. So what we will do, we will place a plotting compass near north. What will happen, as we know, south pole and north pole attract each other and north pole and north pole will repel. So the needle of the plotting compass will somewhat point in this manner, because the tail is the south pole and the head is the north pole. So north pole is repelling the north pole and attracting the south pole. So a plotting compass needle will point in a certain direction. The position where this plotting compass needle is directing, we will mark a point. Is it clear? The first part, how to use or how to plot a magnetic field of a bar magnet using a plotting compass. So what we will do, we will place a bar magnet and place a plotting compass near north or south pole, any pole you can start with. So if you place near a south pole, the like poles will repel and unlike will attract. So a plotting compass needle will point in a certain manner, and the position where the plotting compass needle is pointing, we will mark a point. Example, we label this point as A, or you can say 1. Now what you will do, you will move the plotting compass, or you can use another plotting compass. Now plotting compass is same as the normal compass, like for direction which we use, it's the same thing. The term plotting compass, why it is called a plotting compass, because it can be used to plot the magnetic field of a bar magnet or other types of magnet. That's why another name, you can say compass. So it's the same thing, no difference. So what you will do, you will place another compass. You will place another compass, and until the tail, the tip of this plotting compass in line with the last point which you marked. So you will move this plotting compass, or you can use another compass, until the tail or the tip is pointing towards the last point which you marked. So the last point which you marked, you can see the tip is pointing towards that point. So I will mark another point, and that is 2. Then we will move this plotting compass to new position until the last point which we mark is in line with the needle of the plotting compass. We'll mark another point and say 3. Then we will move the plotting compass until the needle of this plotting compass is in line with the last point which we marked, and we will say that is 4. Again we will move the plotting compass until it will in line with the point which we marked, last point which we marked, that will be 5. And the last point will continue to move until it will end at south pole, and we call that as 0.6 point. So when we remove these compass, when we remove the only the compass, the points will be there. So when I remove the compass, there are points. So if I join these points with a free hand, what I will get? I will get the direction of the magnetic field. So which is a loop here, starting from north and until south. And same way we can repeat from other side. Is it clear how to plot a magnetic field by using a plotting compass? So some general properties of the magnet. Some general properties of the magnet. Magnet have two poles, north and south. A magnet attract the magnetic material. What are the magnetic materials? Some magnetic materials are iron, nickel, cobalt, and steel. These are some magnetic materials. And if there are like poles of the magnet, the like poles, identical poles will repel. And if there are unlike poles, they will attract each other. And around the magnet, there is a magnetic field which is starting from North Pole and ending till South Pole. So this is a magnetic field pattern, the region where the magnet apply force on other magnetic material. This is the pattern of a magnetic field for a bar magnet. And how we plotting a magnetic field lines? So what we can use a bar magnet, a plotting compass, a plain paper, and a pencil, because we'll mark a point. So what we do, we place the magnet on the paper, like here we place a magnet and outline it in boundary, and this is a plotting compass, the compass which I'm. If you bring two iron, like example, this is one iron, this is another piece of iron. Iron is called a magnetic material. There is a difference between a magnetic material and a magnet. Look, what is a example of a magnetic material? Iron, nickel, cobalt, steel, these are known as a magnetic material. Why we call them as a magnetic material? Because first what happened, their domains are random. So domains are random. Originally the domains are not aligned. Even it's a magnetic material. But when you bring a permanent magnet, that moment its domains aligned. So the moment its domain aligned, now this is also behaving like a magnet. This pole will be south, this will be north, and it is attracted towards the magnet. But there are some material which domains, even you bring closer to the magnet. Like example, if I bring a piece of wood, wood is not attracted by a magnet or a magnetic field. What is the reason for that? Because it is having domains, and even in the presence of the magnetic field, these domains will remain random. So if the domains remain random, it will not experience any force. But if domains are lying, it will experience the force and it will be attracted towards the magnet. So a material, originally the material is not having all the aligned domains, but there are some materials which originally in the beginning their domains are aligned, but most of the materials, even it's a magnetic material, the domains are not aligned. Only the domains become aligned in the presence of external magnetic field. So a material can be a magnetic material, it can be a non-magnetic material. So why the two pieces of iron? Like example, I have two pieces of iron, they are not attracting each other. What is the reason? Because both have domains, but their domains are not aligned. So they are not producing a resultant magnetic field. So there is no attraction, even though iron is a magnetic material. So material which experience the attraction in the presence of external magnetic field or a permanent magnet, that is the definition of a magnetic material. So iron, nickel, cobalt, these are magnetic material. Like example, if there is aluminium, aluminium is also a non-magnetic material. in a microscopic level, like example, when you, in a nanoscale, when you break down the material into very small parts, maybe it will become a magnetic. But in a macro scale or a large scale, the material is not a magnetic. Maybe this is a chance. Still there is a research on this. Like you have a piece of wood. A wood is not a magnetic material, but as you are breaking down wood into smaller parts, and a very tiny or small particle of a wood may be a magnetic. So still there is a research, because it is difficult to break down the material into atomic scale, but that is a possibility. So you can understand the concept of a magnetic. Like example, if this is a class, before a teacher enter the class, so once the teacher enter the class, all the students will be aligned, so that will be a magnetic material. But there are some classes and students which do not consider the presence of the teacher, so that class will remain random, or there is no arrangement of the student. So same thing happen for a material as well, that for a material it can behave like a magnet or it can be a non-magnetic, depending on how their atoms act or respond in external magnetic field. Is it clear, the concept of the magnetic material and the magnetic field? Any doubt? So same way we can use a permanent magnet to plot its magnetic field and use a compass. So as you can see, we use a compass, a not a normal compass, and we place this compass around the magnet and work out its magnetic field. This is the actual magnet with the positions of the compass, as you can see. These are the iron fillings, can also be used to align according to the external magnetic field.